There's a number that sounds made up until you sit with it. Some of what's hitting your eyes right now left its source before there was a you to hit. Not metaphorically, not feels old. Actually left, actually travelled, actually arrived tonight, on schedule, having never once stopped moving in between. And here's the part nobody mentions. It didn't slow down for any of it. Not for the part where nothing existed to receive it. Not for the part where it might never have been seen at all. It just kept going. The way a letter keeps being a letter even when no one's home to open it, and eventually, completely by accident of timing, someone was. Start small, start inside it. A single particle of light, a photon, though the word does more harm than good since it makes you picture a little ball, and it isn't one, leaves the surface of something hot, a star most likely. It doesn't leave with a plan, it doesn't leave with a destination. It has no mass, so gravity can bend where it goes but never really slow it down, and it has no internal clock ticking off the years, because from where it's standing, and it isn't standing anywhere, there are no years. That's not poetry. That's the actual physics of travelling at the speed limit of the universe. Time, for light itself, does something closer to stopping than passing. It leaves and arrives in what amounts, to the photon, to the same instant. The billions of years belong entirely to everyone else. You, for instance. You experience the weight. You experience every second of it, sitting here in a body that ages while the thing crossing space to reach you does not. That's the part worth sitting with for a moment before moving on. Not because it's sad, just because it's true, and true things deserve a breath before you keep talking. So it travels. For a long time, there is almost nothing in its way. Space between galaxies is close enough to empty that the photon crosses vast stretches without so much as a glancing interaction, which is its own kind of unsettling if you think about it too hard. An object with no size moving through a distance too large to picture, meeting almost nothing for almost the entire trip. There's a version of loneliness in that, though loneliness might be the wrong word since loneliness requires knowing you're alone, and the photon knows nothing. It just goes. While it's going, the space it's crossing is doing something strange underneath it. The space itself is stretching, not the photon speeding up or slowing down. The room it's travelling through is getting larger while it travels, the way a road might lengthen slightly while you're already driving on it. This stretching pulls at the photon's wavelength, drags it slightly longer, shifts its colour toward red the farther and longer it travels. Astronomers call this redshift, and it's how they measure how old a piece of light really is by the time it lands. The light isn't lying about its age, it's wearing it, quietly, in its colour. Here's the detail I won't explain further tonight. Some of the oldest light we can detect has been stretched so far past red that it isn't light anymore, in any sense your eyes would recognise. It arrives as something else entirely. Leave that where it is for now. Eventually, and eventually, is doing an enormous amount of work in that sentence. The photon reaches something with a surface to land on. Maybe dust. Maybe a leaf on the other side of the planet. Maybe, if the angles align across a distance that took longer to cross than most of Earth's history, your retina. A structure built from proteins that have no idea what they're catching, that fire a signal the instant contact happens, a signal that gets carried up a nerve and translated by something behind your eyes into the sensation you'd call seeing. That's the whole transaction. A particle with no clock meets a structure with a very insistent one, and for one instant they're in the same room together after however long it took to get there. You didn't do anything to earn this. You didn't summon it, didn't angle your head correctly, didn't deserve the timing any more than the dust did. You were just standing in the one place, at the one moment where a very old errand happened to end. It's strange to be the last stop on something that's been travelling since before your language had a word for distance. Stranger still that it happens constantly to everyone without anyone noticing the scale of it. Starlight landing on shoulders, on windshields, on the backs of hands, having crossed unthinkable amounts of nothing to get there. Unremarked, mostly unfelt. Consider for a moment what unremarked actually costs. Somewhere near you tonight, someone is checking a phone, or pouring water, or arguing quietly with a person they love, while photons older than every argument that has ever happened land on the backs of their hands and go completely unnoticed, because noticing was never a requirement for arrival. The universe doesn't wait for an audience. It doesn't check whether anyone is paying attention before it delivers something. It just delivers on schedule, whether or not a single eye happens to be open to receive it. Think about how much of this is happening at once, in this exact moment, all over the surface of everything that can be landed on. Not one photon arriving, not a handful. An amount that stops being countable almost as soon as you start, streaming in from every visible direction, from sources at every possible distance, layered on top of each other so thoroughly that no single arrival stands out from the noise of all the others, and yet each one of them completed its own private individual journey on its own timeline, unaware of all the others doing the exact same thing beside it. There's a strange kind of company in that, even though none of them know they're keeping it. Somewhere out past all of this, more of it is still coming, has been coming the entire time you've been alive, will keep coming after. It doesn't know that. It just arrives. The space between was never empty. Picture the gap between two galaxies, if picturing something with no edges is even the right verb. A stretch of dark so wide that light takes millions of years just to cross the near end of it, and most people, when they imagine that gap, imagine a hallway, long, straight, and above all empty, a held breath between two rooms that matter more than the hallway does. But a hallway waits for you. It has no other job. This space has never once waited for anyone, because waiting requires a kind of attention that empty space simply doesn't have the architecture for. And if there's one thing worth clearing up early, it's that empty was always the wrong word for what's actually out there, filling in the enormous in-between with a thinness so extreme it barely counts as substance, and yet, technically is. There is gas, thin, cold, mostly hydrogen, drifting in concentrations so low that a laboratory vacuum on Earth would be considered crowded by comparison. A handful of atoms per cubic meter in some stretches, sometimes fewer, spread across distances that make handful feel like the wrong unit entirely. There is dust, fine grains of carbon and silicate flung out by dying stars, drifting for ages before maybe someday becoming part of something else. There are magnetic fields, weak but real, threading through all of it like something holding a very loose shape together. None of it was placed there for a photon to pass through. None of it is doing its job with any awareness that a photon might come along at all. That's the part worth sitting with. The sheer indifference of the whole arrangement, The photon crossing that stretch is not being escorted. It is not being protected or guided or aimed. It's simply passing through a region that happens, statistically, to be thin enough that a straight line usually gets you all the way across without colliding into anything solid. Usually, not always, and the not always is where the interesting cases live, but leave those for later. For most of the journey, across most of the distance, it's just going. The way a marble might roll across a floor so vast that the few grains of sand on it barely register as obstacles. Consider what thin actually means out there, in numbers, because numbers are the only honest way to make the word land. A cubic meter of the space between galaxies might hold, on average, less than a single atom. Not a molecule, not a speck of dust you could see under a microscope. Less than one atom spread thin enough across that volume that most cubic meters of that space, sampled at random, would come up completely empty, and the ones that don't would still barely qualify as containing anything at all. Compare that to the air in the room you're sitting in right now, which holds something on the order of 10,000 billion molecules in that same volume, packed so densely that you never think of it as matter at all. You think of it as nothing, as the absence of anything worth mentioning, and yet it is unfathomably more crowded than the space a photon spends most of its existence crossing. Your definition of empty and the universe's definition of empty were never the same word. Zoom in. Zoom past the scale of galaxies, past the scale of stars, down to the scale where gas stops being a cloud and starts being individual atoms, spaced out from each other by distances that are relative to their own size, almost as vast as the distances between stars are relative to a star's size, which is a strange thing to sit with, that the emptiness doesn't really go away no matter how far down you look, it just changes scale and keeps being emptiness. An atom of hydrogen out there might go a very long time in human terms without meeting another atom at all. It just sits, mostly alone, in a version of stillness that has nothing to do with waiting, and everything to do with the plain math of how much space there is and how few things are in it. Zoom in again. Inside that atom, a single proton and, most of the time, a single electron, occupying a structure that is, by volume, almost entirely space itself. The actual mass of an atom is concentrated in a nucleus so small, relative to the whole atom, that if the nucleus were the size of a marble, the outer edge of the atom would be roughly a kilometer away. Emptiness inside the emptiness. It goes all the way down, or at least all the way down to where we currently know how to look. And through all of these nested layers of almost nothing, the photon keeps moving, unbothered by any of it, because it doesn't have a size in the way you'd expect something travelling this far to have a size. It isn't dodging obstacles so much as it's simply not colliding with things that are, by comparison, mostly not there either. Every so often, though, it does collide. It's worth saying plainly because the picture of total unbroken passage is a little too clean to be honest. Across a long enough journey, a photon will sometimes meet a stray hydrogen atom head-on, get absorbed, and vanish as a photon entirely, its energy handed over to the atom, re-emitted later as something slightly different, in a slightly different direction, continuing a version of the same journey under a new name. Multiply that by the scale of the distances involved, and the odd shift from negligible to merely small, which is a different thing. Some light that reaches you tonight took a slightly crooked path to get here, scattered once or twice along billions of years of travel, redirected but not destroyed, a message that got interrupted, rerouted, and still eventually delivered. I keep wanting to call this loneliness, and I keep stopping myself because loneliness needs a witness, and nothing out there is watching itself be alone. What's actually happening is simpler and somehow stranger. The space was never really a hallway. It was never really empty either. It was just very, very thin, all the way down, at every scale you're willing to zoom into, right up until you reach something dense enough to finally get in the way, the speed limit. Nobody set. At some point in all of this, someone always asks the obvious question, the one that sounds almost childish, until you notice nobody actually has a simple answer. Why that speed? Why not faster? Who decided? Nobody decided. That's the honest, slightly unsatisfying answer, and it's worth sitting with instead of rushing past, because the instinct to look for a decision maker is exactly the instinct that has to be set down before any of this makes sense. There was no committee. There was no dial that got turned to a particular setting at the start of everything. No engineer choosing a number and locking it in. The speed light travels at isn't a rule imposed on light from the outside. It's closer to a property of space and time themselves, baked into the geometry of how here relates to there and how now relates to later. Light travels at that speed not because something is pushing it and nothing is holding it back, but because that speed is what moving through space while carrying no mass simply turns out to mean once you write the physics down carefully enough. Try it from a different angle. Nothing with mass can reach that speed, no matter how much energy you pour into accelerating it, because the closer a massive object gets to it, the more energy each further increase in speed demands, climbing toward an amount that would need to be infinite to actually arrive, which is the universe's very patient way of saying no. Only something with zero mass to begin with is exempt from that climb, because the equation that punishes massive objects for approaching the limit simply has nothing to punish in a massless object. It isn't that light is unusually fast, it's that light is uniquely unburdened, and speed, in this specific sense, is just what unburdened looks like. This is a strange kind of speed limit, because it isn't a limit on how fast a thing can go exactly. It's closer to a fixed exchange rate between distance and duration, the same everywhere, for everyone, regardless of how fast the person measuring it happens to be moving themselves, which is the detail that broke physics open a little over a century ago and never quite got put back together the old way. Two people moving at wildly different speeds relative to each other, measuring the same beam of light, will each measure it moving at exactly the same speed, which sounds like it should be impossible, the way adding two different numbers to the same third number should give two different answers, and yet it doesn't, because the universe adjusts something else instead. Space and time themselves stretch and compress around each observer to keep that one number locked in place, unmoving, the single fixed point everything else has to bend around to accommodate. It helps, a little, to stop thinking of it as a speed and start thinking of it as a conversion rate, the exchange between how far and how long, fixed the way the freezing point of water is fixed, not because anyone chose it, but because that's simply where the underlying process happens to sit. None of this makes the number easier to feel. If anything, it makes it stranger, because it means the speed of light was never really about light at all. Light just happens to be the thing that gets to travel at the actual speed limit of the universe, on account of having nothing weighing it down. The limit itself is older than light, older than stars. Built into the structure everything else has to obey. Mass, motion, cause and effect, all of it arranged around a number that nobody set, that nothing enforces, that simply is, the way a shoreline simply is where the land happens to stop. And so the photon leaving that star earlier wasn't obeying a law so much as expressing one. It wasn't being fast, it was simply moving in the only way something without mass knows how to move at all, which, it turns out, is the fastest anything can move. Full stop, no exceptions, no faster lane available to apply for, not for you, not for anything. A number too large to feel. Here's where it usually happens. Someone says the number, and for 1 second, right before the number lands, you're still fine. You're still holding the shape of the conversation. Then the number arrives. 100,000 light years, 1 billion, whatever it is that night. And something in your chest just quietly lets go of trying. I don't think that's a failure. I think it might be the correct response. Light year. That's the word doing the damage. It sounds like a unit of time, the way it's said, but it isn't. It's a unit of distance. The distance light covers in a single year, which is itself already too large to hold, and then you're asked to multiply that by a number with more zeros than feels reasonable, and something in the body simply refuses. I'm not sure refuses is right either. Maybe it just runs out of grip. There's a thing that happens in the chest, or maybe it's higher, in the space just behind the eyes. When a scale shows up that has nothing to do with a human life, not a headache, smaller than that, a kind of pressure that arrives and then, within a few seconds, simply leaves again, because the body can't sustain confusion at that intensity for very long. It tries the number once, fails, and moves on. That's not weakness. That's the body doing something sensible. Say it slowly enough, and the number stops being a number at all. It becomes a sound. Just syllables, arranged in a row, the way any word said 40 times in a row turns into noise. Billion, billion, billion. By the 5th repetition, it's not a quantity anymore. It's a mouth shape. And something about that transformation, quantity dissolving into pure sound, feels like it's telling you something true about the limits of the whole exercise. Try building it upward instead, piece by piece, and see where the grip gives out. 1,000 of anything is already at the edge of what you can picture as individuals. 1,000 people in a stadium section, maybe, still countable in theory, still small enough to imagine walking past one by one. 1 million stops being individuals almost immediately and becomes a texture instead, a crowd, a stretch of sand rather than grains. 1 billion is 1,000 of those millions stacked, and by then the picture hasn't just gotten bigger, it's gone somewhere else entirely. The way a word repeated too many times stops meaning and starts being noise. Now attach light year to the end of that number so that each single unit in the pile is itself an almost incomprehensible distance, and you're not stacking blocks anymore. You're stacking things that were already too big to stack. You were never built for this scale. Nobody was. Human bodies evolved to judge distance across a savanna, across a room, across the length of a spear throw. Distances where misjudging by 10% might mean a wasted afternoon of walking, not a black hole's worth of error. Somewhere in the skull is a whole set of finely tuned tools for estimating how far is that thing, and none of these tools have ever, in the history of the species, been asked to process a light year, let alone 100,000 of them stacked end to end. So the dizziness that shows up isn't malfunction, it's the correct reading from an instrument being used outside its range, like weighing a mountain on a kitchen scale. There's an old trick teachers use to try to close the gap, at least part way, and it's worth trying here even knowing it will fail, eventually the way all the tricks eventually fail. Shrink the sun down to the size of a marble. At that scale, the nearest star to it, not counting the sun itself, sits roughly the length of several football fields away, alone, with nothing of consequence in between. Shrink the whole galaxy down using that same ratio, and the model doesn't fit in a room, doesn't fit in a city, doesn't fit in a country. It stops being a model you could build with your hands and becomes a description you can only hold as an equation. The trick works for exactly as long as it takes to say the second sentence, and then the scale outruns the metaphor the same way it outran the number. I want to say this passes quickly, and it does, but I think what's actually happening is a little sadder than passing. It's more like the mind quietly decides the number isn't going to be felt tonight, and files it under things to be known rather than things to be understood, and moves on to something the body can actually hold. You can write the number down. Anyone can write it down. Writing doesn't require feeling, but there's a difference between knowing a number is true and knowing what it means, and I'm not sure that gap ever fully closes for anyone, no matter how many times the number gets said out loud in the dark. The photon does not age. It's already arrived by the time this sentence starts, which means everything interesting about its trip is over, filed away, done. And what's left to talk about isn't the arrival itself, but the strange bookkeeping underneath it. The fact that whatever happened during the trip left no mark on the thing that made it. No mark at all. Not fatigue, not decay, not even the ordinary wear that time leaves on everything else that exists. Consider what happened along the way while it was crossing all that distance, because a great deal happened, even if none of it happened to the photon directly. Stars formed out of collapsing clouds of gas somewhere near its path, burned for millions or billions of years, and in some cases finished burning entirely, collapsing down into remnants dense enough to warp the space around them, all while the photon kept going, entirely unaffected, entirely unaware, because awareness was never part of its equipment to begin with. Somewhere else along a similar path, on some unremarkable rocky world, chemistry accumulated into something that could copy itself, and copying turned, over an amount of time too long to feel in one sitting, into something that could think about copying, and eventually into something sitting in a room at night wondering about a piece of light it hasn't even received yet. And all of that, the entire unlikely arc of life becoming aware of itself, happened in less time, cosmically speaking, than the photon spent simply crossing the space between one galaxy and the next. None of it touched the photon. None of it slowed it, warmed it, aged it, marked it in any way a scientist could later detect. Here's the part that still gets me. Even now, even after going over this so many times, I should probably be used to it by now, from the photon's own reference frame. And I use that phrase carefully, because talking about a photon's reference frame is already stretching language past where it's comfortable. No time passes between emission and absorption. None. Special relativity says, plainly, that for anything travelling at the speed of light, the interval of proper time along its path is exactly 0. Billions of years pass for everyone else. 0 passes for it. It left and arrived in the same instant by its own accounting, no matter how long the trip looked from where you were standing. It's worth being precise about what reference frame even means here, because the phrase gets thrown around loosely, and the looseness hides how strange the actual claim is. A reference frame is, in the simplest terms, a way of measuring space and time from a particular point of view. Your watch, your ruler, your sense of before and after, all calibrated to how you happen to be moving. Every observer with mass moving at any speed less than light gets a valid reference frame, a coherent story about how much time passed and how far something travelled. A story that will differ from someone else's story but will still hang together internally, still make sense on its own terms. A photon doesn't get one of those. The mathematics that would define a photon's reference frame breaks down entirely, refuses to produce an answer, the way dividing by 0 refuses to produce an answer. Physicists talk about the photon's perspective as a kind of limit, a direction things point toward as an object gets closer and closer to light speed, rather than a place any actual observer could stand. It's less a viewpoint than the edge past which viewpoints stop being definable at all, which makes the 0, in its own strange way, more honest than a story would be. It's not that the photon experiences an instant, it's that the very idea of the photon experiencing anything is a question physics can't quite finish asking. I've sat with that fact for longer than I probably should have, on more nights than I'd like to admit, and I still land somewhere different each time. Some nights it sounds like the loneliest sentence in physics, something that experiences nothing, participates in nothing, carries no memory of any of the history it passed through, arriving blank, untouched, indifferent to everything it crossed to get here. Other nights it sounds almost like relief. Something in this universe got to skip the wait entirely. Something got to leave and arrive without ever having to sit inside the gap between the two. You didn't get that option. Nothing alive gets that option. You experience every second of every year between one event and the next, whether you want to or not, aging through all of it. And there's no version of physics that lets a living thing opt out of that the way a photon simply does, by virtue of having no mass to weigh it down into time's slower lane in the first place. There's an asymmetry worth naming plainly here, because it's the whole point dressed up in smaller clothes. Mass is what buys you a place inside time. It's the toll you pay for the privilege of experiencing a before and an after it all, of having memory, of having a story that unfolds instead of simply existing all at once. The photon, having no mass, pays no toll and gets no story. You, having plenty of mass in the grand cosmic scheme, pay constantly in seconds, and get in return every single one of the moments the photon skipped entirely. It arrives the same as it left. Everything around it during the trip became something else entirely. Stars were born, stars ended, whole biographies of matter played out along the route it happened to be crossing, and it carried none of that forward, arriving small, unbothered, and completely unchanged, which might be the loneliest fact in this whole outline, or the least lonely, depending entirely on the night you're having when you hear it. Everything you see is a corpse of a moment. You probably think you're seeing the room as it is right now. Fair assumption. Everyone makes it. It's also, strictly speaking, not quite true. And the gap between true and not quite true here is so small in most cases that it never matters, except that the gap is real, and it exists everywhere, at every scale, all the time, whether it's noticeable or not. Light takes time to travel, even across a room, even across the 6 feet between your eyes and the person sitting near you. There's a delay, a fraction of a billionth of a second. So small it might as well not exist for any practical purpose. And yet it does exist, technically, the same way the delay to the moon exists, just wildly different in scale. The face across the room, not current, slightly late. A report, not a broadcast, widen it out. The moon, when you look at it, is roughly a second and a half behind. Not the moon itself, which is fine, wherever it is, but the image of it, the light your eyes are currently catching, which left its surface a second and a half ago, and has been travelling toward you this whole time, arriving now, telling you what the moon looked like a moment you've already lived through and forgotten. Widen it further. The sun. 8 minutes gone by the time its light lands on your skin, which is a strange enough fact on its own, but leave that one alone for now. It gets its own room later. Keep going, and the gap stops being trivial. A star you might point at tonight, if you know where to look, could be one whose light left hundreds of years ago, arriving only now, telling you what it looked like during a war you've read about in books, a war fought by people who never once looked up and thought about the fact that the sky itself was writing them a very long letter. There's a version of this that becomes almost comic if you let it, and almost unbearable if you let it a little further. Every photograph you have ever taken is, in the most literal sense possible, a photograph of the past. Not metaphorically, not in the wistful way people mean when they say a photograph captures a moment that's gone, but mechanically, physically, because the light that hit the camera's sensor had already finished travelling from the subject to the lens by the time the shutter closed, meaning the image was already historical the instant it was recorded, before anyone had even looked at it once. You have never once seen a photograph of the present. Neither has anyone. The category doesn't exist. And then, pull back in, fast, down to the room again, down to the lamp on the table, down to your own hand in front of your face, because here's the part that always gets missed in the widening. The gap doesn't stop at some outer boundary of far enough to count. It's the same gap structurally, whether it's a nanosecond or 400 years. Your hand right now in front of your face is also slightly late. Not by an amount you could ever notice, not by an amount that changes anything about how you live. But the mechanism doesn't have a cut-off where it turns off, and reality becomes instant. It's delay, all the way down, all the way out, without exception. Everywhere light is involved at all. Push it further still, past your hand, into your own eye, into the very apparatus doing the looking. There is a delay between light striking your retina and your brain finishing the work of turning that signal into the experience you'd call seeing, somewhere in the range of 1/10 of a second, sometimes more, spent converting chemistry into electricity into meaning. Your brain, in other words, is not showing you the present either, even setting aside the travel time of the light itself. It's showing you a briefing, assembled slightly after the fact, stitched together so seamlessly that you never noticed the seam. Because a brain that showed you every delay honestly, every gap between event and awareness, would be a brain too slow to keep you alive. So it lies gently, constantly in your favor, presenting the recent past as though it were the current moment, because for every practical purpose that has ever mattered to survival, the lie is close enough. You live permanently a few footsteps behind the present. Everyone does. It's baked into the geometry of the universe. Not a flaw, not a glitch, just the plain cost of information having to travel instead of simply existing everywhere at once. And until fairly recently in human history, nobody even knew to ask. And here is the strange, quiet, almost restful thing at the bottom of it. None of this has ever once bothered you. Not tonight, not any night before this one. You've lived your entire life a few footsteps behind the present, wrapped in a delay so total and so seamless that it never registered as anything at all, and you were somehow completely fine. The sun you watch is 8 minutes dead. Right now, as you're reading this, the light hitting whatever's near you that's lit by daylight left the sun 8 minutes and 20 seconds ago, give or take, depending on where Earth happens to be in its slightly uneven orbit that day, and it's been in transit this entire time, crossing 93 million miles of mostly nothing, arriving exactly now, having no way to arrive any faster because nothing can. Sit with the number for a second. 8 minutes. That's shorter than most songs, shorter than most commutes. It sounds almost trivial when you say it out loud, a gap so small compared to the light years discussed earlier that it barely feels worth mentioning at all. But 8 minutes is long enough for everything to already be over. If the sun stopped existing this instant, and it won't, not for a very long time, so there's no need to panic about this specific scenario. But if it did, right now, this second, you would have no way of knowing. Not for 8 more minutes. The sky would look exactly the same. The warmth on your skin, if you were standing in it, would keep arriving, uninterrupted. Because that warmth is also light, already in transit, already committed to finishing its journey regardless of what happened at the source after it left. You'd keep basking in something that no longer exists, sunburned, potentially, by a ghost. That's not a metaphor stretched too far. That's the literal mechanics of it. The sun you're seeing right now, and the sun that currently exists in the actual present moment, are two different objects occupying the same coordinates in your sky. One of them real and current, existing exactly as it exists at this instant, and one of them a delayed broadcast, a recording finishing its playback, having no updated information about anything that's happened since it left. Only one of them can hurt you, and it isn't the one you're looking at. This is true, by the way, of everything the sun touches, not just the light arriving at your eyes, the warmth on your arm, the reason plants grow, the entire climate of this planet running on a delayed feed from a source that could, in principle, be doing something completely different right now, and you wouldn't know for 8 more minutes. Everything alive on Earth is currently operating on old information. It's worth pausing on how strange that arrangement actually is, once you look at it plainly, instead of letting it slide past as trivia. Every living thing on this planet, every leaf converting light into sugar, every eye squinting against noon, Every migratory bird timing its flight to the changing angle of daylight is responding not to the sun as it is, but to the sun as it was 8 minutes ago. The entire machinery of life on Earth has been built over billions of years around a signal that is permanently, unfixably out of date, and it has never once mattered, because the sun is reliable enough on the timescale that matters to biology that the 8-minute lag might as well not exist. Evolution didn't need real-time information. It needed information that was true often enough, and 8 minutes turned out to be close enough to instant for every purpose life has ever had. Not stale exactly. The sun isn't likely to have changed much in the last 8 minutes. So for all practical purposes, the delay changes nothing that matters to your day. But it's not nothing either. It's a real structural fact about how this entire relationship works. You and the sun have never once interacted in real time. Not once, not ever, in the whole history of anything alive looking up at it. Every sunrise you've ever seen was already 8 minutes old by the time it reached you. Push the thought a little further, and it starts to feel almost tender in a strange way. A sunrise is, technically, the arrival of a message that was sent before the colour in the sky existed as an event in the present tense. The sun, in its own actual now, has already moved 8 minutes past the version of itself you're watching rise, has already continued on however it continues, oblivious to the fact that a planet 93 million miles away is only now catching up to something it already finished doing. You are always watching a slightly outdated performance of a star that has already gone on to do something else. The very first light of the very first sunrise, and the very last light of whatever sunset eventually turns out to be your last. Both of them running the same 8-minute lag, the same fixed shipping time, the same rule with no exceptions, because the rule doesn't know or care what it's carrying. There's no version of looking directly at the present, not with the sun, not with anything. Starlight and the dead. Find a constellation tonight if the sky where you are is dark enough to bother. Any of them. The shape doesn't matter, and neither really does the name someone gave it long ago, tracing lines between points of light that have nothing to do with each other except sharing, by pure coincidence of angle, the same rough direction from Earth. What matters is a quieter fact sitting underneath the shape. Every point of light in it left its source at a different time from a different distance. And what you're looking at is not a picture, it's a collage. Two stars that appear to sit side by side, forming a corner of some ancient hunter or bear or queen, might be nowhere near each other at all. One of them 20 light years away, the other 400, lined up only by the accident of standing in roughly the same direction when viewed from exactly where you happen to be standing. Move a few hundred light years in any direction, and the shape falls apart entirely, resolves into two unrelated points scattered across a completely different piece of sky. The constellation was never a real object. It was always a trick of perspective, drawn by creatures small enough and rooted firmly enough in one exact spot to mistake a coincidence of angle for a picture. And each of those 2 points is showing you a different year, not a different moment within the same story, a genuinely different chapter from a genuinely different book, stitched together only because your eye, standing exactly where it stands, happens to receive both signals on the same night. You're not looking at a scene. You're looking at a scrapbook assembled by geometry of light that has nothing else in common except its destination. Here's the harder part, the one that tends to sit differently once you've actually sat with it. Some of what you're looking at is gone, not dimmed, not distant. Gone. The source itself finished, collapsed, scattered, existing now only as whatever it became after it stopped being a star, while its light, sent out before any of that happened, is still arriving faithfully on schedule, having no way to update itself with the news. A star ending is not a quiet event on the scales that matter to it. Some of them go out slowly, cooling over spans of time too long to picture, fading through colours as they run down. Others end all at once, in an explosion bright enough for a short while to outshine every other star in the galaxy it happens to be sitting in, an ending loud enough to be seen across almost the entire visible universe, and yet, from Earth, indistinguishable from any other point of light until the moment its very last message finally arrives. Which means, somewhere in the sky tonight, above whatever roof you happen to be under, there is very likely a point of light that no longer has anything behind it. Not one, probably. Statistically, more than one across the whole visible sky on any given night. Though there's no way to know in advance which ones, no marker distinguishing the living stars from the already finished ones, because the light itself carries no notice of what happened after it left. It looks exactly the same, whether the source is still burning or has been gone for centuries. You could be looking at a corpse right now and calling it a landmark, steering a ship by it, naming a season after it, falling in love under it. None of that requires the star to still exist. It only requires the light to still be arriving, which it will keep doing, faithfully, for as long as the journey it already started takes to finish. Sometimes centuries after there's nothing left to visit if you somehow found a way to travel there yourself. There's an old, slightly grim joke among people who spend their lives looking up at this. Every star chart is a kind of obituary column that hasn't been updated yet, and won't be, not for a very long time, not until every last delayed letter currently in transit finally finishes arriving, and the sky quietly, gradually, rearranges itself to admit what's already true. It rearranges itself slowly enough that no single night ever shows you the change. You'd have to live for centuries watching the same patch of sky to catch even one of those lights finally going out for good, the signal ending, the last photon already sent, nothing behind it anymore, the point simply going dark the way a lamp goes dark once the switch has been off long enough for the filament to stop glowing. Nobody alive has ever watched that happen to a star they knew by name. It happens too slowly on a human clock to be witnessed even once in even the longest human life. Which means the sky above you tonight is, in a very real sense, older than it looks. A photograph of a moment that has already, in places you can't identify, quietly stopped being true. Between here and the edge, there's a boundary out there, somewhere past everything we can currently detect, and the strange part isn't that it exists. Boundaries exist everywhere. The strange part is why this particular one exists, which has nothing to do with distance being too great to cross and everything to do with time simply not having happened yet. Not blocked, not too far, just not yet arrived because there hasn't been enough universe in terms of elapsed time for the light to have made the trip. I find this harder to hold on to than most of the other facts in this outline, and I'm not entirely sure why, except maybe that it asks you to think about the universe as something with an edge made of time rather than space, which isn't how edges usually work in ordinary life, where an edge is a place, a location, somewhere you could point to on a map if you had a big enough map. This edge isn't a place, it's a moment. It moves as time moves. Right now, this instant, there is light crossing space toward Earth that left its source so long ago and had so far to travel that it is only now, tonight, arriving here for the very first time, meaning somewhere out there, this exact moment, is the very first time anyone or anything with eyes could have seen that particular light, ever, in the whole history of anything looking. Stop. That's worth sitting inside for longer than a sentence normally gets to sit. Somewhere, right now, someone, if there is a someone, and there might not be, this works the same either way, could be looking up and seeing something for the first time that has been in transit since before Earth existed, before the Sun existed, arriving on schedule, having waited for nothing and no one, simply completing a trip that happens to conclude on this particular night, for this particular observer, purely by the accident of standing in the right spot when the delivery finally lands. There's a name for this outer boundary in the language people use who spend their careers thinking about it. The observable universe, and the phrase is doing careful, deliberate work, because it is not a claim about how big the universe actually is. Nobody knows how big the universe actually is, and there's a real possibility nobody ever will, because the honest answer might be that it has no edge at all, that it simply continues past the point where any signal from it could ever reach us, forever, or at least for long enough that forever and long enough stop being meaningfully different words. The observable universe describes something much smaller and much stranger. Not everything that exists, but only the portion of everything that has had time to send us a letter since the whole thing began. Everything past that boundary might be perfectly ordinary. More galaxies, more stars, more of the same thin, drifting, almost nothing described earlier, stretching on in every direction, completely unremarkable in itself. What makes it inaccessible isn't strangeness. It's simply that not enough time has passed since the universe began for anything from out there to have crossed the distance to here. And by the time enough time has passed, the universe itself will have grown larger in the meantime, meaning the boundary is not a fixed wall waiting to be reached, but something closer to a horizon that keeps receding as you approach it. A target that grows the moment you get closer. We are always slightly behind the edge of what exists to be seen, not because we're slow, because the edge itself keeps moving, keeps advancing outward as more time passes and more light finishes trips that were already underway before we were born, and there's no way to catch up to it. Because catching up would require light itself to move faster, and nothing does. I keep drifting back to the same discomfort with this one. The edge isn't a wall. It's not a place we haven't reached. It's a place that hasn't finished happening yet. From our position, even though from somewhere else, from wherever that light actually started, its story is long since over. So the universe has an edge, but the edge isn't out there, the edge is now. The edge is whenever now happens to be, for whoever happens to be looking, and it will be a different edge tomorrow, farther out, because a little more time will have passed and a little more light will have finished its trip. The edge keeps moving. So do we, in our own way. carried forward by the same passage of time that's letting the boundary expand, both of us drifting outward together, neither one ever quite catching the other. How we know how far? None of the numbers in this outline were simply announced. Somebody had to measure them, and it's worth pausing on how, because the method turns out to be its own small, strange story, built entirely out of tricks for squeezing distance out of light when there's no tape measure long enough to do the job directly. The first trick is old, older than telescopes even, and uses nothing more exotic than the fact that your two eyes see slightly different views of anything close enough to you, which your brain quietly combines into a sense of depth without you ever noticing the calculation happening. Widen that same trick out to an enormous scale. Instead of two eyes a few inches apart, use the two positions of Earth on opposite sides of its orbit around the Sun months apart, and a nearby star will appear to shift very slightly against the background of much more distant stars, the same way a nearby lamppost seems to shift against a distant skyline when you look at it first with one eye and then the other. Measure that tiny shift precisely enough, and simple geometry hands you the actual distance. No assumptions required beyond trusting the angles. This trick, called parallax, is honest and direct, and it is also almost uselessly limited in range. The shift gets smaller the farther away a star is, and past a certain distance it becomes too small to measure at all, even with the most careful instruments, leaving the vast majority of what's out there completely untouched by this first, most trustworthy method. So astronomers needed a second trick, one that could reach farther, and the one that eventually worked relies on a strange coincidence involving a particular kind of star that doesn't shine steadily, but pulses, brightening and dimming on a regular cycle. The length of that cycle tied, reliably, to how intrinsically bright the star actually is. Find one of these pulsing stars anywhere, time its cycle, and you can work out how bright it truly is, independent of distance. And once you know how bright something actually is, comparing that to how bright it merely appears from here tells you, through nothing more complicated than the same math describing why a lamp looks dimmer the farther away it's carried, exactly how far away it must be. These pulsing stars became, in effect, standard candles, objects whose true brightness is knowable in advance, making their apparent dimness a direct, reliable readout of distance, reaching vastly farther than parallax ever could, all the way out to other galaxies entirely, a leap that, when it was first made, roughly a century ago, quietly overturned the assumption that our own galaxy was the entire universe. Farther still, past the range even those pulsing stars can reach, a third trick takes over, relying on an entirely different, considerably more violent kind of standard candle, a very specific type of stellar explosion, one that reliably detonates at almost exactly the same true brightness every single time it happens, regardless of which galaxy it happens in or how old the star that produced it was. Spot one of these explosions anywhere, however distant, and the same brightness versus distance math applies again, this time reaching far enough to measure galaxies whose light left before the sun existed. Stack these tricks end to end, parallax handing off to pulsing stars handing off to exploding ones, and you get what astronomers sometimes call a distance ladder, each rung calibrated against the one below it, each one reaching farther than the last, none of them working in isolation. all of them checked constantly against each other for consistency, adjusted whenever a discrepancy shows up, refined over decades by exactly the kind of patient, careful work that eventually replaced tired light with genuine expansion in the last chapter's story. Every number in this outline, every distance mentioned so casually as though it were simply known, is standing on top of that ladder, built by generations of people who never got to see most of what they were measuring, who spent careers timing the flicker of stars they'd never visit, comparing brightness against brightness, so that eventually, someone much later, sitting in a room at night, could say a number out loud and have it mean something more solid than a guess. How we know how far. None of the numbers in this outline were simply announced. Somebody had to measure them, and it's worth pausing on how, because the method turns out to be its own small, strange story, built entirely out of tricks for squeezing distance out of light when there's no tape measure long enough to do the job directly. The first trick is old, older than telescopes even, and uses nothing more exotic than the fact that your two eyes see slightly different views of anything close enough to you, which your brain quietly combines into a sense of depth without you ever noticing the calculation happening. Widen that same trick out to an enormous scale. Instead of two eyes a few inches apart, use the two positions of Earth on opposite sides of its orbit around the Sun months apart, and a nearby star will appear to shift very slightly against the background of much more distant stars, the same way a nearby lamppost seems to shift against a distant skyline when you look at it first with one eye and then the other. Measure that tiny shift precisely enough, and simple geometry hands you the actual distance. No assumptions required beyond trusting the angles. This trick, called parallax, is honest and direct, and it is also almost uselessly limited in range. The shift gets smaller the farther away a star is, and past a certain distance it becomes too small to measure at all, even with the most careful instruments, leaving the vast majority of what's out there completely untouched by this first, most trustworthy method. So astronomers needed a second trick, one that could reach farther, and the one that eventually worked relies on a strange coincidence involving a particular kind of star that doesn't shine steadily, but pulses, brightening and dimming on a regular cycle. The length of that cycle tied, reliably, to how intrinsically bright the star actually is. Find one of these pulsing stars anywhere, time its cycle, and you can work out how bright it truly is, independent of distance. And once you know how bright something actually is, comparing that to how bright it merely appears from here tells you, through nothing more complicated than the same math describing why a lamp looks dimmer the farther away it's carried, exactly how far away it must be. These pulsing stars became, in effect, standard candles, objects whose true brightness is knowable in advance, making their apparent dimness a direct, reliable readout of distance, reaching vastly farther than parallax ever could, all the way out to other galaxies entirely, a leap that, when it was first made, roughly a century ago, quietly overturned the assumption that our own galaxy was the entire universe. Farther still, past the range even those pulsing stars can reach, a third trick takes over, relying on an entirely different, considerably more violent kind of standard candle, a very specific type of stellar explosion, one that reliably detonates at almost exactly the same true brightness every single time it happens, regardless of which galaxy it happens in, or how old the star that produced it was. Spot one of these explosions anywhere, however distant, and the same brightness versus distance math applies again, this time reaching far enough to measure galaxies whose light left before the sun existed. Stack these tricks end to end. Parallax handing off to pulsing stars handing off to exploding ones. And you get what astronomers sometimes call a distance ladder, each rung calibrated against the one below it, each one reaching farther than the last, none of them working in isolation, all of them checked constantly against each other for consistency, adjusted whenever a discrepancy shows up, refined over decades by exactly the kind of patient, careful work that eventually replaced tired light with genuine expansion in the last chapter's story. Every number in this outline, every distance mentioned so casually as though it were simply known, is standing on top of that ladder, built by generations of people who never got to see most of what they were measuring, who spent careers timing the flicker of stars they'd never visit, comparing brightness against brightness against brightness, so that eventually, someone much later, sitting in a room at night, could say a number out loud and have it mean something more solid than a guess. Each one sending light that had been travelling for its own enormous stretch of time before finally landing in that one patient exposure. Some of the faintest, smallest smudges in that image are not nearby galaxies that simply look small because they're faint. They are among the most distant objects ever recorded, galaxies whose light left them when the universe itself was young enough that young barely describes it, a fraction of its current age back when the ingredients for stars and galaxies were still assembling themselves out of the raw aftermath of the beginning of everything. Sit with what that photograph actually is. Once you stop calling it a photograph and start calling it what it really is, a time machine pointed outward instead of backward, catching, all at once, in a single patch of sky, light that left at wildly different points across almost the entire history of the universe, layered on top of each other by the accident of all arriving here, now on the same night, having taken very different lengths of time to do it. It is not a picture of a place. It is a picture of a very great many different times, all landing on the same patch of film simultaneously, because simultaneously here only describes the arrival, never the sending. Every one of those smudges of light was already old news by the time the exposure caught it. Some of those galaxies, as they exist right now, in their own actual present, no longer look anything like the faint smudge recorded in that image. They've grown, merged with neighbours, aged in ways their own light hasn't caught up to reporting yet, because that light is still crossing the distance between what they were and what they are, one photon at a time, arriving in order, telling an old story to anyone patient enough to gather it. Some of those galaxies, if you want to follow the thought all the way to its uncomfortable end, might not even exist anymore in any form that resembles a galaxy at all, might have already run through their own long biography and finished, collapsed, scattered, and there is no way from here tonight to know which ones. The photograph doesn't distinguish between the living and the finished. It only shows what left, faithfully, exactly as it left, regardless of what happened afterward. What that image actually proves, more than anything else it shows, is how much has always been hiding in plain sight, in patches of sky dismissed as empty simply because nobody had yet been patient enough to let the faint ancient light finish arriving. The dark spaces between stars were never as empty as they looked. They were just holding letters that hadn't finished being delivered yet, addressed to whoever eventually got around to waiting long enough to receive them. A universe that cannot show you itself. There's an even older piece of light than any galaxy, older than any star, older than the very first structures that ever managed to pull themselves together out of the raw material of the early universe, and it's worth stopping on because it isn't light from an object at all. It's light left over from a moment, the closest thing available to a photograph of the universe's own infancy, and it arrives from every direction at once, evenly, faintly, filling the entire sky rather than pointing at any one place in it. For a long stretch after everything began, the universe was too hot, too dense, too chaotic for light to travel freely at all. Matter existed as a churning, glowing fog, charged particles packed close enough together that any photon trying to move through it was immediately scattered, absorbed, re-emitted, scattered again, trapped in an endless local exchange, unable to get more than a short distance before running into something else. Light existed, it just couldn't go anywhere. The universe in its youngest phase was opaque, the way the inside of a thundercloud is opaque, the way steam fills a room and swallows the light of a single bulb before it can cross more than a few feet. Then, as everything expanded and cooled, something shifted. The charged particles slowed down enough to combine into stable, neutral atoms, and the fog that had been scattering every photon in existence simply cleared. Suddenly, for the first time, light had somewhere to go. It stopped being trapped and started travelling in every direction, freely, for the first time in the universe's entire existence, and it has been travelling, uninterrupted, ever since. That first burst of freed light is still out there, still arriving right now, filling the whole sky evenly because the fog cleared everywhere at roughly the same time, meaning that no matter which direction you look, you're looking at light that has been in transit since that exact moment, stretched by the expansion that's happened since into wavelengths your eyes were never built to catch, arriving not as visible light anymore but as something much longer, much fainter, detectable only with instruments built specifically to listen for it. It is, in effect, the oldest photograph in existence, except it isn't a photograph of any object. It's a photograph of the moment the universe itself became transparent, the instant everything stopped being fog and started being sky. Here's the part that tends to catch people off guard the first time it's said out loud. This means there is a wall of sorts, past which no telescope, however patient, however well built, will ever be able to see. Not because the light from further back is too faint, because there is no earlier light to find. Before that moment, the universe wasn't transparent enough to let any photon travel freely at all, meaning nothing from before it was ever released to reach anyone, anywhere, ever. It isn't hidden. It's genuinely, permanently unavailable, the way a letter that was never mailed can't be found no matter how thoroughly you search the delivery system. Everything before that boundary is invisible, not because it's distant, but because light itself hadn't yet been granted permission to leave. There's something almost strangely comforting buried in that limitation if you sit with it long enough. The universe has kept exactly one thing permanently private, the very earliest chapter of its own story, sealed off not by secrecy, but by the plain physical fact that nothing could travel freely enough back then to carry the news forward. Every telescope ever built, every one that will ever be built, is aimed at a sky that has already told us almost everything it's capable of telling. Everything, at least, that was ever released to travel. The speed of now. Here's a question that sounds simple enough to answer in a sentence and isn't. What is happening right now on a star 400 light-years away? The honest answer is that the question doesn't quite mean what it sounds like it means, and the reason why is one of the stranger consequences of everything discussed so far, one that tends to unsettle people more than the distances themselves ever do. Right now feels like it should be a single, shared moment, the same instant everywhere, ticking forward in lockstep no matter where you're standing to watch it. That's certainly how it feels, moment to moment, in an ordinary life. Your now and a friend's now, sitting across the table from you, are close enough to identical that the tiny mismatch between them, caused by the finite speed of the light and sound passing between you, never registers as anything at all. But stretch the distance out far enough and add in the fact that different observers, moving at different speeds, don't just experience delay differently. They disagree, in a precise and measurable way, about which distant events even count as simultaneous with their own present moment in the first place. Two people, moving relative to each other, each perfectly correct according to their own physics, can look at the same two distant events and reach opposite conclusions about which one happened first. Not because either of them made an error, not because the light hadn't finished arriving yet, because at the same time was never actually a fixed universal fact to begin with. It was always relative to how fast the person doing the asking happened to be moving, a detail invisible in ordinary life because ordinary speeds are far too slow for the disagreement to ever show up in any way you could notice. There is no cosmic master clock, ticking the same universal beat for everyone, that all of these separate nows are secretly checking themselves against. There's no room, somewhere at the centre of everything, where the real, authoritative, present moment is being kept, the way a country keeps an official time zone. Every observer's now is its own separate, locally valid thing, agreeing with nearby observers closely enough that the difference never matters, and disagreeing more and more as speed or distance increases, without any of the disagreeing observers being wrong. Which means the question, what is happening right now on a star 400 light-years away, doesn't have a single correct answer. Even in principle, even with perfect information, even if every obstacle of distance and delay were somehow removed, there is no fact of the matter about what a distant place is doing right now, relative to you. Because your now and its now were never actually stitched together into one shared present tense to begin with. The light that eventually reaches you tells you what happened there, according to a version of there that only makes sense once you specify whose clock, moving at what speed, gets to define when then was. This is a harder fact to sit with than the mere delay discussed earlier, because delay at least implies an answer exists somewhere, waiting to be caught up to. This implies something stranger, that the question itself was built on an assumption, a single shared universal present, that simply isn't true anywhere for anyone and never was. You've spent your whole life inside, and now that felt obviously real, obviously shared, obviously the same now everyone else is standing in. It never once occurred to you to doubt it, because at the speeds and distances of an ordinary life, the illusion is completely seamless. It only comes apart out here at the scale of stars and galaxies, where the seams were always there, just too fine to see, the light that will never arrive. Not everything out there is simply waiting its turn. Some of it has already, quietly, permanently, stopped being reachable at all. Not because it's too far in the ordinary sense of far, but because the space between here and there is growing faster than light can cross it, which sounds like it should be against the rules, and, in the strictest sense, isn't. Nothing can travel through space faster than light. That rule holds absolutely without exception everywhere it's ever been tested. But space itself isn't a thing travelling through space. It's the stage everything else travels on, and there's no law preventing the stage itself from stretching at any rate at all, including rates far in excess of light speed, once you're talking about distances large enough. 2 points, far enough apart, can be moving apart from each other faster than light, not because anything is moving through the space between them that fast, but because the amount of space between them is simply increasing everywhere at once at a rate that adds up quickly once the distance is large enough to multiply against, which means there are galaxies right now whose light will never reach us. Not yet, never. The space between here and there is expanding quickly enough that any photon they send in our direction will spend its entire existence losing ground instead of gaining it, swallowed by the growing distance faster than it can close it, never arriving, not in 1 billion years, not in any number of years, because the finish line is retreating faster than the runner can approach it. There is a boundary out there, distinct from the one discussed earlier, marking the difference between light hasn't reached us yet but eventually will, and light will never reach us no matter how long we wait. And unlike the first boundary, which simply moves outward as time passes and more of the universe becomes visible, this second boundary is, in its own way, closing in. As the expansion continues, more and more galaxies that are currently still just barely reachable will cross over into the category of never reachable, one by one, their last possible message already sent, or about to be, after which nothing further from them will ever arrive here again. Some galaxies we can currently see are already, in this sense, gone to us in a different way than the dead stars discussed earlier. Not necessarily finished, not necessarily destroyed, but permanently beyond any future contact. Their most recent news already the last news we will ever receive, with everything that happens to them from this point forward sealed off by an expanding gap neither side can close. There is something in this that resembles grief, though it's a strange kind, aimed at something that was never a relationship to begin with. The door closing slowly on places we never visited and never will, whose future we will simply never learn, not because anyone chose it, but because the room itself is quietly getting larger faster than a voice, however loud, however patient, could ever hope to cross it. And it is happening this exact moment in every direction, to some number of galaxies we currently think of as merely distant rather than permanently out of reach. The line moving tonight, while you read this, without any ceremony, without any way of even knowing precisely which lights just crossed it. bent light and borrowed images. Not every strange thing that happens to light on its way here has to do with distance or speed. Some of it has to do with weight, with the simple fact that anything with enough mass bends the space around it, and light, having no mass of its own to resist the bending, has no choice but to follow the curve. The way a marble rolled across a stretched sheet of fabric will follow whatever dip a heavier object has pressed into it, whether the marble wants to or not. This means light doesn't always travel to you in a straight line, even when a straight line would seem like the only sensible option. If something massive enough sits between a distant source and your eye, a galaxy, a cluster of galaxies, an amount of matter large enough to visibly dent the space around it, the light from whatever's behind it gets bent around the obstacle instead of blocked by it, arriving not as a single clean image but sometimes as multiple images of the same object, smeared into an arc, or split into several separate copies scattered around the object doing the bending, all of them technically true, all of them the same original light, just delivered along paths of different lengths. Different lengths of path mean different amounts of travel time, even for light that left the same source at the same instant. A photon that took the long way around a massive obstacle can arrive later than one that took a slightly shorter route past the same obstacle, sometimes by days, sometimes by weeks, occasionally by far longer, meaning it's possible, in the right circumstances, to see several images of the same event, from the same source, arriving at noticeably different times, each one a genuine, unaltered copy of something that happened only once, simply delayed by different amounts depending on which bent path it happened to travel. There's something almost unsettling about that, once it's said plainly. An event that happened exactly once, in exactly one place, can show up on your sky more than once, at different times, looking slightly different each time depending on which route the light took to get here. Not because anything happened more than once, but because the space it travelled through offered more than one way to arrive. Astronomers have used exactly this trick more than once to measure things that would otherwise be nearly impossible to measure, timing the gap between the arrival of one bent image and the arrival of its delayed twin to work out how much space itself has stretched in between, turning a strange side effect of gravity into an actual instrument, a natural accidental piece of measuring equipment assembled out of nothing but mass and light and unimaginable distance, built by no one, calibrated by no one, simply existing because the universe happens to bend the way it bends. It's worth sitting for a moment with how strange it is that this works at all, that a chance arrangement of galaxies sitting in exactly the right alignment relative to Earth, and some much more distant source behind them, becomes, by pure accident, a lens. Not shaped by anyone, not polished by anyone, not designed with any purpose in mind, simply massive enough in exactly the right spot to do the job a lens does, magnifying and duplicating and delaying an image it never asked to bend. None of this requires the light itself to do anything unusual. It's still travelling in the straightest possible line available to it the entire way. It's the space itself that isn't straight, curved by the mass sitting in it, and the light is only ever doing what light always does: follow the shape of the room it happens to be in, however that room happens to be bent, without complaint, without deviation, without any awareness that the room was ever anything other than perfectly ordinary from where it was standing. What the sky sounds like. if you listen long enough. Everything said so far has quietly assumed a narrow definition of light, the kind your eyes happen to be built to catch, a thin sliver of colour squeezed between red and violet, chosen not because it's special, but because it's simply the range that happened to be useful to a species evolving under a particular kind of star. It's worth widening that definition before going any further, because almost everything interesting that's ever arrived from deep space has arrived in wavelengths your eyes were never built to notice at all. Radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays. All of it is the same basic phenomenon, the same electromagnetic disturbance, the same speed limit, the same rules about redshift and travel time and arriving late, differing only in how tightly or loosely the wave happens to be wound. Visible light just happens to be the one narrow band your retina evolved to catch, out of a spectrum that stretches, in both directions, almost unimaginably further than the thin strip you can actually see, which means the sky has always been shouting in registers you were never equipped to hear, and it was only ever a matter of building the right kind of ear. A radio telescope doesn't see anything in the ordinary sense. It listens, in a manner of speaking, for wavelengths stretched far too long for any eye to register as colour, catching signals from the coldest, quietest, most spread out material in the universe. The same thin gas discussed earlier, glowing faintly in wavelengths invisible to biology, but perfectly audible, so to speak, to the right kind of instrument. An X-ray telescope catches the opposite end of the spectrum entirely, the violent end, the wavelengths thrown off by matter, falling into the crushing gravity of a collapsed star, heated to temperatures no ordinary light could carry information about, screaming out in a register too tightly wound for any eye to have ever evolved a use for. Put the two images together, the radio picture and the X-ray picture taken of the exact same patch of sky, and they barely look like they're depicting the same place at all, because they aren't showing you the same thing. They're showing you two entirely different stories, both true, both arriving from the same direction, both invisible to you unless something was built specifically to catch them. Every picture of deep space you've ever found beautiful, every glowing nebula, every dramatic swirl of colour is very often a translation rather than a photograph. Light gathered in wavelengths no eye could ever see, assigned to colours your eyes can process, purely so the information could be handed to you in a form you're actually built to receive. The true colour, if a wavelength outside your visible range can even be said to have a colour at all in any meaningful sense, was never the point. The information was the point. The colour is just the costume it's wearing so you can look at it directly, which raises an odd, quiet question worth sitting with before moving on. How much of what's arriving right now in every direction, in every wavelength at once, is simply passing straight through you, unnoticed, uncaught, because nothing in your body was ever built to register it? The answer is almost all of it. You're standing at this very moment in a bath of ancient signals stretching across the entire electromagnetic spectrum, and your eyes are catching only the thinnest possible sliver of what's actually arriving. A sliver chosen not because it's the most important part of the message, but because it happened to be the part most useful to a creature trying not to get eaten on a particular planet, orbiting a particular kind of star a very long time ago. The light that left before. There were eyes. the light that left before there were eyes, start at the moment of departure, inside the event itself, at the instant a photon leaves the surface of something hot enough to make it, an electron dropping to a lower energy state inside an atom, releasing the difference as a small packet of light that immediately, with no delay, no hesitation, no gathering of momentum, is already moving at the only speed it knows how to move at, heading out into a universe that, at the time, contained nothing built for the specific purpose of receiving it. No eyes yet. Not on this world, not on any world nearby, possibly not on any world at all, depending on how far back this particular photon story goes. It leaves anyway. It has no destination programmed into it, no target, no sense of purpose or audience, and it simply goes in the direction it happened to be aimed at, the moment it was emitted, indifferent to whether anything would ever be positioned to catch it, indifferent really to the entire concept of being caught, since indifference itself requires an awareness this photon has never once possessed. For most of its existence, and depending on the photon, most could mean a majority of billions of years, that was simply the honest state of things. A signal sent with no listener anywhere along its path. A broadcast into a universe with no ears yet built to hear it, no eyes yet built to see it, no minds yet assembled that could turn its arrival into the private, wordless experience of seeing something. It kept going regardless. It had no other setting. Meanwhile, unrelated to the photon, entirely unconnected to its specific path, matter elsewhere was doing something slow and strange. Consider how much had to happen in order, none of it guaranteed, all of it eventually arriving at the very specific outcome of an eye. A cloud of gas and dust had to collapse under its own weight into a star and the leftover scraps orbiting it. Those scraps had to cool, over ages, into something solid enough to call a planet. That planet had to land, by chance, at a distance from its star neither too close nor too far, in the narrow zone where water can exist as a liquid, rather than freezing solid or boiling away entirely. Chemistry on that planet's surface had to stumble, without any plan or intention behind the stumbling, into a molecule capable of making rough copies of itself, and those copies had to compete and fail and improve across a length of time too long to hold as a single thought, until eventually, among an almost incomprehensible number of failed attempts, one lineage developed a patch of cells sensitive to light at all. Not an eye yet, nothing so refined, just a smudge on some ancient creature's surface that could tell the difference between light and dark. Enough of an advantage to be worth keeping, worth refining, generation after generation, into something curved, then something lensed, then, eventually, into the specific, exquisitely tuned instrument sitting in your skull right now, capable of catching a single photon that left its source before any of this had even begun. None of that development had anything to do with any specific photon in transit. It just happened, on its own schedule, in its own corner of the universe, while an enormous number of unrelated photons kept travelling through space that increasingly, if extremely gradually, contained things that could receive them. It's worth pausing on the sheer improbability of the timing, because it's easy to state the sequence as though it were inevitable, and much harder to sit with how easily it might never have happened at all. The photon had no way of knowing an eye was even a possibility, let alone that one would eventually exist along its exact path, pointed in exactly the right direction at exactly the right moment. It was simply moving the entire time through a universe that happened eventually in one specific location among an almost uncountable number of other locations where nothing of the kind ever occurred, to grow something capable of catching it. Then, at some point, and there's no way to know for any specific photon which point that was, an eye opened somewhere, pointed in roughly the right direction at roughly the right moment, and caught something that had been travelling the entire time without ever knowing there would eventually be something worth travelling toward. Zoom out from that single collision, all the way out past the eye, out past the planet, out past the billions of years the photon spent as nothing but a signal with no destination. And here's what's left once the scale is fully wide again. An ordinary, unremarkable fact, small enough to say in one plain sentence, sitting quietly underneath everything that came before it in this chapter. It was never travelling toward you specifically, and it didn't need to be, because eventually, somewhere, something was always going to be looking. And here is the part worth carrying forward. Past this chapter and into everything after it, you are, yourself, made of the same basic material this whole story keeps circling back to. The atom sitting in your hand right now, the calcium in your bones, the iron carried through your blood. All of it was forged inside stars that finished burning long before the sun existed, scattered outward by the same kind of violent ending discussed earlier, drifting for ages through the same thin, almost nothing a photon crosses, before eventually gathering into the cloud that became this solar system, this planet, and, eventually, you. You are not simply the audience for old starlight. You are, in a very literal sense, made out of it. A slower, heavier, more complicated arrangement of the exact same raw material, assembled by the same universe, out of the exact same ingredients, just given considerably more time to become something that could look up and wonder about where the rest of it went. The weight of waiting. Somewhere in the middle of all this, the redshift, the delay, the edge that keeps retreating, it's worth turning the telescope around for a moment and pointing it at the one thing in this entire outline that actually experiences any of it. You. The photon, as established, pays nothing for its trip. No years pass for it, no matter how many pass for everyone watching it go. You are built entirely differently, and it's worth being precise about what that difference actually costs, instead of letting it stay an abstraction. You wait in a way nothing else in this outline waits. A rock doesn't wait. A rock simply persists, unbothered, indifferent to how much time passes around it. The same before and after in every way that matters to a rock. A star doesn't wait either. Not in any sense that involves experience. It burns, and burning isn't waiting. It's simply a process unfolding at its own rate, with nothing inside it accumulating a sense of how long any of it is taking. Waiting requires something specific, a mind capable of holding a before, comparing it to a now, and noticing that time has passed in between, whether or not anything of note happened during the gap. That capacity is expensive. It's also, as far as anyone currently knows, exceptionally rare, scattered thin across the universe the same way atoms are scattered thin across the space between galaxies. Plentiful in exactly one very small, very specific location, as far as we can currently confirm, vanishingly rare or entirely absent everywhere else that's ever been checked. which means the billions of years a piece of starlight spends in transit are, from the universe's own accounting, mostly uncounted. Nothing along most of that path is keeping track of how long the trip is taking. No clock is running, no calendar is being marked, no sense of duration is accumulating anywhere in all that vast, thin, drifting, almost nothing, until, finally, near the very end of the journey, the light happens to cross paths with one of the rare places where a clock is running, where duration is being felt rather than merely elapsing, where someone is, in fact, waiting. You are one of the only things in this entire story capable of noticing how long any of it takes. That's worth sitting with on its own, apart from everything else. Every calculation in this outline, every number too large to feel, every fact about redshift and delay, and the edge of the observable universe, all of it required at some point a mind capable of holding the concept of a long time well enough to even ask the question in the first place. The universe doesn't experience its own scale, it just has scale. Something has to show up eventually capable of noticing, or the scale simply exists unregistered, the way a number exists whether or not anyone bothers to write it down. You noticing is not a small thing, even though it's easy to treat it as incidental to the physics, a footnote to the real story rather than a genuine part of it. The redshift would still happen whether or not anything was ever built to measure it. The delay would still exist whether or not anything was ever built to feel the weight. But the weight itself, the actual experience of time passing, the specific, felt difference between a moment and the moment after it. That only exists because something like you eventually showed up to hold it. There's a strange kind of responsibility buried in that, if you're willing to call it a responsibility rather than just a fact. Somewhere in the vast, silent stretch this whole outline has been describing, a very small number of things are doing something the rest of the universe simply isn't equipped to do. Keeping track, marking time, noticing that a night has passed, that a number was too large to hold, that the light landing on a hand tonight has been travelling since before that hand, or any hand, existed to receive it. Nothing required you to notice any of this. The photon would have landed on your retina whether you thought about any of it or not. The same reflexive transaction it would have completed on any other surface. Dust, a leaf, a wall, with exactly the same physical result and none of the accompanying wonder. The wondering was extra. Nothing in the mechanism demanded it, and yet here you are, having spent this much time on it anyway, turning a plain physical transaction into something worth sitting with, worth feeling, worth being kept awake by on certain nights for reasons you couldn't fully explain even to yourself. That's not nothing. In a universe this large, mostly silent, mostly unmarked, mostly unnoticed by anything at all, the noticing might be the rarest event in the entire story. Rarer than the collapse of a star, rarer than the birth of a galaxy, rarer, possibly, than anything else this outline has mentioned so far. Two kinds of company. There is a small amount of light by comparison to everything discussed so far currently leaving this planet on purpose, sent outward not by a star but by something built here, deliberately, by hands, aimed at the dark with an actual destination in mind, however faint the odds of ever reaching one. A handful of spacecraft launched decades ago have long since left the immediate neighbourhood of the Sun, and are drifting, at this moment, through the thin, mostly empty space discussed earlier, carrying with them a small disc etched with sounds and images meant to explain, to whatever might eventually find it, what it was like to be alive here, once, briefly, on a particular planet orbiting a particular star. Greetings recorded in dozens of languages, a recording of a mother's heartbeat, music, chosen carefully, meant to stand in for the sound of a species that would very likely be long gone by the time anything ever encountered the object carrying it. Compare that gesture to everything else in this outline. A star doesn't choose to send light outward with a message attached. It simply radiates, indifferent to whether anything is out there to catch it, the way every photon discussed so far has been indifferent the entire time. This is different. A rare case of something in this universe sending a message on purpose, aimed outward not at a specific destination, but at the mere statistical hope that something, somewhere, eventually, might be in a position to receive it. It is, in its own small way, the same gesture the eye eventually made toward the ancient photon discussed earlier, just running in reverse. Instead of something evolving slowly, blindly, to catch a signal already in transit, this is something building a signal on purpose and releasing it into a void with no better odds of ever being caught than any of the ordinary starlight drifting past it. The math on this is almost aggressively unkind. Space, as established, is close enough to empty that most straight lines drawn through it cross vast distances without encountering anything solid at all. A small object, deliberately launched, aimed roughly in the direction of a few nearby stars, is, statistically, exceedingly unlikely to ever pass close enough to anything to be noticed, let alone recovered, let alone understood. The people who built it knew this. They sent it anyway. There's something worth sitting with in that decision, apart from the physics. It is, in its own way, an act of the same kind discussed in the last chapter. A species capable of noticing the scale of all this, capable of feeling the weight of the silence surrounding it, choosing deliberately to add one more small, deliberate signal to a universe otherwise filled almost entirely with the accidental kind. Not because the odds favoured it, because the alternative, saying nothing, sending nothing, letting the silence remain completely uninterrupted by anything but the ordinary, indifferent output of stars, felt apparently like the wrong way to spend the opportunity. Two kinds of light are moving through the dark right now, doing very different jobs. One kind left billions of years ago from a source with no plan and no destination, indifferent to whoever might eventually catch it, arriving here tonight purely by the accident of your retina happening to be in its path. The other kind left decades ago, deliberately, from a source that thought carefully about what to include and what to leave out, aimed outward with something that almost resembles hope attached to it, however thin the odds of it ever landing anywhere at all. Both are travelling at exactly the same speed. Neither one is more real than the other, or more likely to arrive, or more meaningful in any way physics is equipped to measure. The only difference between them is a decision, made once, briefly, on one particular night, by one particular species, to try sending something outward on purpose instead of simply waiting, the way everything else in this story waits for whatever happens to arrive